Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome everyone. Thanks for joining us on Happy Path Programming. Today we have with us John DeGoes, and I'm so excited about this one. We've wanted to talk to John for a long time, and just some background. John, I think I probably first encountered you in the Scala community, and then got to know you a lot better as you started working on Zio. And when I saw Zio, I was just like, oh my God, this is amazing. Zio is exactly how I want to program in Scala. And
Thank
so,
you.
yeah, it just was everything I dreamed of, but I didn't dream of it. You dreamed of it, which was amazing. So
Well,
welcome,
thank you
John.
for
Great to
saying
have
that.
you.
And it's good to be here. Thanks for the invitation. I've listened to
So,
many of your episodes.
And you've actually been up here to Crested Butte a bunch of times.
Oh, yes. I have loved Crested Butte. I fell in love with that little town in the mountains.
Yeah.
No, in the mountains. I will be count on that.
Yeah, we'd love to have you back anytime. So we've talked about Zio on the podcast a number of times, and so I don't know if we need to dive into Zio stuff, but the topic that I think is we want to start is kind of your journey with Scala and Rust. You've been doing more with Rust lately, and I just want to hear like your perspective on why Rust, why not Scala, that kind of stuff.
And yeah, and also kind of, I mean, from reading your posts, it's like you've figured out a bunch of things about Scala and where it's going, and a lot of things in line with my own experiences, I think.
Yeah.
Scala is a great experiment.
Yes.
But
yeah. I think that first off, I like Scala. I'm a fan of Scala. And even after almost 15 years, I think, with the programming language, I'm still a fan of Scala and I actually like to write Scala. And that's why nights and weekends, you will often find me contributing to Zio open source projects and writing Scala. I still teach in Scala. So obviously I love the language, and I don't want to dissuade anyone who loves the language from learning it and using it and even building companies on it. Because I often tell startup founders, oh, look, your company's not going to fail because you picked Scala or because you picked PHP or Haskell or whatever. Like, the number of companies who fail because they picked the wrong programming language is almost zero. Just pick something and go with it. And if you end up like Twitter, you could actually make a whole ecosystem successful because of your choice to pick something that you personally liked. So I don't want to dissuade anyone. At the same time, having been on this journey with Scala for a long, long, long time, you have to look hard to find anyone who's been with Scala for as long as I have. I've sort of seen its whole rise thanks to Spark and various other things at the time. Twitter and Spark, I think, were the two big bumps for Scala, but also the lack of options on the JVM and immaturity and lack of innovation in Java. Just lots of things around that contributed to the rise of Scala. And then I've also been there for the less fun times when you see Scala adoption waning and companies moving from Scala to other programming languages, back to Java, and of course to Kotlin and to Go and to Rust. And honestly, I think at this point I better understand why it is some languages go on to become commercial industry focused languages and other languages go on to become playgrounds for experimenting with new ideas and pushing forward state of the art in research and academia. And right now, at this point, everything I've seen, I sort of see Scala's on the path to being more of a language where people can learn about new language features and about how they impact the ergonomics of programming and the safety of programming and our ability to combine different paradigms and so forth. And there's nothing wrong with that. I don't want to bad talk that. But also, for me personally, my primary programming language is not only a passion, and it's not only something I like to do nights and weekends, it's also a career. And so one also has to think about, what does it make sense from a career perspective? And for my own personal journey, I recently, early this year, I think, got to the point where I'm like, it makes sense for me to make a switch to and start investing in other programming languages that are more focused on the needs of industry that are going to have much bigger markets. And why Rust in particular? Well, there's a few things I really like about Rust. First off, Rust is basically, I think, appeals to, of all the systems programming languages out there, Rust will appeal most to Haskell developers and Scala developers. Because a Haskell developer and Scala developer, we're not afraid of type systems. We
Yeah.
don't care, bring it, right?
Yeah.
Define types, okay, yeah, let me see more of this stuff. Associated types, why not? So a borrow checker, okay, well, that's something new. That's something we have to wrestle with because we don't have anything like that in Scala or Haskell. We do have higher kind of types, and we have type families and associated types and type level programming and implicits and givens and all this other fun stuff. And all this type level machinery, it helps us write safer code. And it's the same for Rust, right? Advanced type system that helps you write not only safe code, like memory safe and concurrency safe code, but also gives you very real practical advantages to the business, something they care about. They want to save on infrastructure costs. They want low latency. They want high reliability. They don't want exploits. So Rust gives you this package of features that is not only very interesting and intellectually stimulating and challenges you, even if you're an expert Haskell developer or Scala developer, but also these benefits can be sold. I talk about that a lot. It's like come up with a tagline that you can sell. And I can sell Rust. It's like, do you want safety? Do you want performance? If so, use Rust.
Yeah.
And for Scala, it's like, do you want to fuse functional programming and object-oriented programming? Okay, use Scala. And that's the official pitch. It's been the official pitch of the language for quite some time. It's perhaps the wrong pitch, but it
Yeah.
is the pitch. It's the pitch of the language. And for Rust, it's just like, hey, you want it to be safe? You want it to be fast? Okay, choose Rust. It's
Yeah.
an obvious, no-brainer choice for that subset of applications where you need that utter safety as well as super high performance.
So
And
as
especially
you
with the work. Go ahead.
So as you were looking at, all right, maybe time to start looking at something beyond Scala. There's a whole host of newer modern languages out there.
Yes.
You've got Unison, you've got Rock, you've got
Yeah.
Flix, and I'm curious about. I'm sure you looked at all these, but it sounds like one of the angles that you were considering everything through was what is the trajectory of these languages to
Yes.
get to something kind of more general purpose,
That's
more
right.
industry widely adopted in industry, that sort of thing. So,
That's right.
but there's probably I'm sure you've looked at those other languages, and there
All
may
of
be
them.
things that are more attractive in some of those than
Oh,
Rust.
yeah.
But I'm
Yeah.
curious your perspective on that.
Yeah. So, for example, Flix is a really interesting language that is Scala-like syntax, but it deletes some of the most painful features of the Scala programming language, cleans it up quite a lot, and also adds a bit of logic programming. So, from like an intellectual standpoint, I'm really fascinated by Flix. And it would not be a hard sell to convince any Scala developer to give Flix a try. But it's still super early stage. In fact, it's earlier stage than the Scala programming language. And one has to accept a certain amount of, like, the market for Flix programmers is almost zero. Maybe not quite zero, but it's almost
Yeah.
zero. And the market for Scala developers is small. So that's one of my concerns is like, how big is the market right now? And
Yeah.
what will the market be like in 5 years? Flix, you don't know because you don't know which path they're going to go down. They're very much focused, I think, on exploring the boundaries of what's possible, but they've not yet said, hey, we want this to be an industry focused language. We're going to commit to stability and great tooling. We're not going to change stuff, even if we find a better way to do something, right? That's a commitment that you have from Java. Even if there's a better way of doing something, Java will just ignore it. And that sounds terrible, but also it sounds wonderful because it means you don't have to update all your code and not everything is breaking every few weeks.
Yeah.
So
As Brian Getz says, they have the last mover advantage.
they do, and that's an advantage.
Yeah,
It's
it
not
is.
an advantage to everyone, but if you have a business to run, then it's a big advantage. And then Rock, I love Rock. Man, Rock is is something I'm just keeping an eye on, is like a Christmas present, because it's Richard Feldman, who worked on Elm for a long time, and super passionate about that community, and has done amazing things, and also is a big believer in Rust, by the way. He gets
Well,
what
because he
it
wrote Rock
takes.
and
Yeah, the
Rust.
Rock compiler
Yeah,
is written in
that's
Rust.
right. Yeah, he gets what it takes for a language to be accessible and focused on ergonomics. And he's also passionate about functional programming. And also, he's got his business hat on, and he's like, well, if only FP were faster, right? FP has to be fast enough that you don't have to care about performance. It doesn't have to be as fast as Rust or C, but as long as it's fast enough that people can't come, oh, this, we shouldn't be using this, we should switch to something else, you're safe. So I think Rock actually stands a chance of being more, probably the most popular purely functional programming language out there. I really do think that, and I think that he can get the ergonomics right. He can make the case to the business. I am super excited about that language, but it's just so early stage
So
that
early, yeah.
you can't consider it for another few years at the very least.
Yeah.
And if you're trying to build a career around it, not going to work just yet.
Yeah.
And then
Yeah.
the other ones, I've taken a look at all of them, and they're all very interesting. I think there's pros and cons to each one. But if you look at like what gives you a lot of power and type safety and FP like features like algebraic data types and derivation of type classes, all that good stuff, and has a very strongly vertical trajectory, great ecosystem, good tooling, lots of jobs. The list has one language on it.
Yeah.
It's just Rust.
Yeah.
There's basically no choice right now. I think if you're interested in all that stuff, it's got to be Rust.
Yeah.
And I love how, I don't know, solid it feels, and how many of the bases that they've covered when it comes to tooling, it's just like,
yeah.
Trying to set up a Java project with Gradle. It's like,
Yes.
I don't. Whereas with Rust, it's just, cargo new and
it's
cargo
amazing.
run, and it just goes. And it's like, I don't know. For someone who makes a lot of examples,
Yes.
it's like so attractive.
Yeah.
So
Rust
appealing.
tooling gives me joy. And
Yes.
I have not been delighted by tooling since my IntelliJ IDEA days with Java. Like I truly am delighted by IntelliJ IDEA with Java. Just so much joy and happiness just from using a tool. And it's been a long time since those days. And Rust is really, from the compiler error messages to the ergonomics of cargo to the features of Rust Analyzer when you're using VS Code. And I'm about to try Rust Rover dedicated.
That's right. Just announced this week. Yeah.
From JetBrains.
Yeah.
So I have high hopes. I'm blown away by the tooling and the commitment to tooling. The commitment to tooling and the commitment to stability. And those are things that make me think this is a language that wants to be used by big companies on large, long-lived code bases. And that just gives me hope that they're going to invest in these things that matter to industry.
And I don't know about you, but my experience learning Rust, it's with all the languages that I've learned, it's always like, oh, this is cool, this is cool. And then it's, oh, well,
you reach the point where you find the disappointment.
They didn't really think, and it's really strange. With I keep waiting for the other shoe to drop. There must be something, because every time I learn a feature, I go, wow, they really thought this out and they did it right.
Yeah.
And I don't know. It's just really
not a typical experience with programming languages. It's like, how quickly do you find the sharp edges in a language and the things that you're disappointed by? And with Rust, that's pretty far back. I think there are some things like you mentioned, async await not being the best.
The
async
kind of is a bit of a pain point, but it gets the job done.
Yeah.
And in the future, who knows? What I know, there's a lot of proposals to simplify.
Exactly.
Exactly.
Would you consider Rust to be a functional programming language?
It's in a weird state. I actually don't think it's a functional programming language, and that's because it does not make programming with functions easy. You can program with functions, but it's not easy like it is in many other languages. And Rust really wants you to, first off, you do have great algebraic data types. fantastic type classes and instances and derivation of instances. So you have a lot of FP goodness, and
Can
you
I
can program in an
interrupt
FP
you for
way.
a
Go ahead.
second? What do you call? I mean, I've never fully understood type classes in Scala. So
Yeah,
you say Rust has type classes. What is?
Traits.
Oh, it's just traits.
yeah, that's right.
But
Oh,
so here's a
but
question,
traits
real
just
as
make
a
total
sidetrack.
sense to me, whereas type classes never do.
Yes,
So I think it's interesting you say it's not a functional programming language, but it certainly has some elements of functional
it
programming.
does.
But what's
Yeah,
weird is that they don't use the functional programming vernacular. Like they don't
They don't
call
want to scare
traits
people
no,
off.
type classes. They don't call
yes,
their result thing a monad.
Right.
They, like
that's right. That's right. And I think that that's a good move. It's one of the things I
Brilliant.
tried to do with Zio is delete all the jargon and terminology that was off-putting to
Mhm.
people. And I think that that makes a difference. You would think it doesn't, but it actually does. The difference between calling something a monad and not even calling it anything, just saying here's a data type you use to store the result of a function makes a huge difference
It
in
does.
how many people are too afraid to approach the technology and give it a try.
yeah,
It's the top of the funnel stuff,
yeah.
basically.
Yeah, it's kind of wild how just certain words can push people away. And I think
Yes.
Rust has done a good job of not using that terminology. And
Yeah.
then maybe at some point people realize, oh my God, I'm using type classes from functional programming, and oh my God, I'm using monads, and
Exactly.
it's like had no idea, but oh, there they are.
That's right.
Yeah,
And my enums and my
yeah,
structs were
ADTs and
actually
yep,
sums and products, right?
yep,
It's
exactly.
you can
Yep.
learn that later if you learned it at all. There's no
If
need
you
to call
want.
these things any particular names if you want. Yeah.
Mhm.
Yeah. So, as you've been diving into Rust, what are some of the things that you look at and say, like, oh, I missed this from Scala?
Yeah, there are definitely things that I miss from Scala. I think one of the obviously I miss Zio, right?
Yeah.
There's a big difference in Zio. Just feels like I don't know, just a high end Rolls Royce or something, and it has every sort of luxury feature, and it's just very pleasant to use Zio to solve even complicated problems. And you can solve problems using Rust, and the libraries they are very good, but it does not have the same level of polish and everything sort of fitting together perfectly and just making very short work of virtually any problem in concurrency or sort of resilience. It doesn't have that yet. And I do miss that. At the language level, though, I think one of the things that I miss is the ability to refactor code
Hmm.
without having to think about implications on concurrency or memory. So
Hmm.
concurrency and memory related implications. You can just move stuff around anywhere, and you don't have to think about that. And particularly with respect to lambdas, I, as a functional programmer, I use quite a lot of lambdas and functions and function composition, and that's much more painful. And there's many
Hmm.
more things you have to prove. So refactoring, I would say, and the sort of FP style of build functions and compose them is much more difficult. And I miss just the fluidity, I think, that a language like Scala gives you on both accounts.
Could there be some kind of Zio for Rust?
I think there can be, yes.
Okay.
And I'm trying to sort of think through exactly what that should look like. And should it be like agnostic with respect to runtime? Should it be Tokyo specific? Like exactly what it should look
Hmm.
like there. But I do think that there is an opportunity for someone to come in and produce this sort of opinionated, cohesive way to do concurrency and asynchronicity and error management, all that great stuff that you come to Zio for. And I think that could be built in a way that integrates with the existing ecosystem rather than tries to replace anything. And that was hard in Scala because there really wasn't anything. But in Tokyo, you do have really great async runtimes like Tokyo and the async standard that you could use, I think, to form a foundation for something that provides a holistic solution for concurrency and async related and resiliency problems.
Yeah. Yeah, and the air channel stuff I think is
Yeah.
would certainly be nice because as one
Yeah.
thing I ran into was, oh, okay, I've got a result of a option of a whatever, and like figuring out how to then munge that
Yes.
with a deferred of a result
Yes.
and like combine the air channels. It got a little. I was like, oh
For
yeah,
sure.
I definitely miss Zio on this this part.
Although there's one nice thing, like in Scala, we had to work hard to teach people about typed errors, right? Because before Zio, that wasn't the thing.
Yeah.
It was all just throwables everywhere.
Throwables, yeah.
And in Rust, they already believe in typed errors.
Yeah.
Maybe because they don't have a choice, but there's always typed errors. So I think that's a little bit less of a hurdle and can have better integration with the core fallible data type in Rust, which is result.
Yeah. Yeah. It
Less
seems like
evangelism.
philosophically there's a good similarity between Zio and Rust around error handling with
That's right.
panics and then ADTs for using
Exactly.
ADTs for
It maps to sort of fatal things which you shouldn't handle, and then the things that you expect to happen and which you should handle.
And that's so basic, and it's taken me so long to get that, deep
It took me a
understanding.
super long time too to even understand that.
It's
Once
like,
you see it, I think that not all errors are the same, right?
well, yeah,
Some of them we expect and we want to handle, and some of them we don't.
you
And if we
can't
like
do
static
anything about.
programming,
You just report, but even just, well, and I think it's been a lot of the languages that have just punted, when something goes wrong, return a null or something
right.
like that. These,
Yeah.
And we got used to it and just go, oh, errors, they happen
Yeah.
to somebody else. That's not
Yes.
something I need to. And then when you actually start seeing it, you go, no, we really need, that's a thing that needs to be part of everything that we
That's
look
right.
at.
And it seems to me like every failure has taught us something, like Java checked exceptions teaching us something, right?
Yeah.
We don't want everything to be checked because programmers just program around that.
Mm-hmm.
So we want a balance of worlds, and also we want errors, I think, to be values so we can use them in abstraction. Or if not values, then you need to be able to sort of abstract around duplication like you can with values, and you can't do with checked exceptions. I feel like all these experiments in error handling, they've taught us something. And now maybe we're at the place where maybe we don't know, like we probably don't even all agree on the mechanisms of error handling, but we're at least a lot of people who have been programming as long as we have are like, okay, there actually are some patterns here that it would be nice to codify for best practice error management.
And including resource management as part of that, because that was obviously one of the big things that Java, I think, hasn't gotten right is
yes,
what's the relationship between errors and the resources and the handling, and how much ceremony do you need to be able to handle correct closure on air of a resource, and will that be reliable? Can it run async in the background? All the things obviously that Zio just gives us a framework for out of the box.
That's right.
Nicely, but.
Yeah, the other thing it's made me think a lot about is exception handling, which I thought about it ever since I was exposed to it in the C++ standards committee. It's like, this is weird. And now I understand why. It's like, it's a side effect that is basically out of control. It's just like,
exactly, a black hole from this part of your program to another seemingly random part.
Maybe another part of your program. We don't know.
We don't know.
Yeah, you don't know.
You don't know.
How many code bases have you seen with try catch with nothing in the catch clause?
Yeah.
When you invent a bad feature, programmers make it like you can't force them to do things in one way. They just do what they're going to do. So when you give them something that's bad, they just work around it, creating more problems.
Mm-hmm.
Yeah.
One of the things I learned is you can't educate a programmer to do things in the best way. They're going to do whatever the language sort of, forces them to do, guided by the path of least resistance.
Yeah.
Yes.
So how about metaprogramming in Rust versus Scala? Both have metaprogramming. I haven't built any macros in Rust, but obviously use them often.
They're all over the place.
What's your thoughts on the differences in metaprogramming models?
Yeah, I think, I admire the Rust approach. They're at opposite ends of the spectrum. So metaprogramming in Scala started from this sort of staged metaprogramming idea that was typed and that uses quotes and splices, and there were academic papers on it, and it's very, very elegant and very beautiful and can solve a lot of interesting problems, including the staged metaprogramming, which can do some interesting things at runtime. And then Rust, on the other hand, its metaprogramming is okay. We're going to call your macro code, and we're going to feed you in a stream of tokens, and you're going to produce a stream of tokens as output. And there's been higher level stuff, of course, that has been built on top of that. But it's like, what's the simplest thing we could do that would be more reliable than a C defined macro, which is terrible. And they implemented that, and it is amazingly powerful. It is not elegant. It's not elegant at all. There's no academic theory behind it.
But it's
But
accessible.
it's accessible, extraordinarily accessible. And also it's like a unified means of doing anything you want. Like you can implement a trait for a type using a macro. You can add functions to a trait or to an impl. You can create new data types, right? You can create new structs and new enums and do whatever you want. And so therefore you can use a macro to solve all of the problems that you would otherwise have to turn to printing out code to do.
Yeah.
And then the Scala approach was elegant and nice and beautiful and all these academic papers. And it turns out you can only solve a few interesting problems with that. And then for all the other problems, you've got to resort to a lower level sort of tree DSL that was baked in because the first mechanism was just not powerful enough. And even the mechanism we have today in Scala 3.3 is not powerful as the Rust one. You can't make new data types. And so there's a huge section or segment of problems in Scala 3.3 dot whatever we're up to now that you cannot solve except by printing Scala code. Meanwhile, that Rust metaprogramming mechanism, which probably has barely changed since the first day, can solve all these problems, right? And people hate on the Rust macro system because it's so primitive, but at the same time, it gets the job done. And it can do more than Scala can do after many years of research and papers and production. So I understand the appeal of both, and there are things that I like about both. But at the end of the day, just give me something simple that works, that everyone can understand, and that you can do everything that you want to do with it. And so that would be the Rust macros, in my opinion.
And how do macros impact the tooling system? Because I know that was always one of the challenges in the world of Scala was the macros were considerably breaking the tooling. The IntelliJ would give you red squigglies because the macros were doing magical things under the covers that IntelliJ didn't know about. And do you have some of the same problems in the Rust world of the macro system confusing the tools?
Yes, but the tooling is better because there's just way more investment into the tooling. In the Rust side, there's more people working on it. There's more like corporate interest. I think that there's dollars behind it. Hence why we're getting a Rust IDE from JetBrains. I think there's dollars in that community. So I am very happy that it's a commercial product, and I will happily give them money in order to help invest into tooling in Rust if it turns out that Rust Rover is great. So I think that even though there are problems, even now you can go to your macro and you go to definition in VS Code with Rust Analyzer will show you the code that it generates.
Nice.
And also with Rust Analyzer, it's not like you're getting red squigglies. It understands, this code was generated and I'm using the generated code. So with VS Code and Rust Analyzer, it's good. With the Rust plugin in IntelliJ IDEA, it's gotten better. And then I expect probably even better things eventually from Rust Rover.
Yeah. Well, it seems like with the foundation that's there for essentially like AST transforms or something, it sounds like the macro system in Rust, you could then build higher level things on it, like Scala's match types or whatever, on top of that foundation. So you could bring the higher levels of abstractions. Okay, they already
people have, like there's this high level way to write a macro that involves basically pattern matching on expressions and then replacing those by other code. It's like the quote and splice mechanism of Scala. And so people can experiment with these things and they can come up with new ways to do something, and all of that can still run on that very low level mechanism of token streams. So that means it can exist forever, right? We can keep on experimenting. We don't have to change the language necessarily because the experimentations can happen in user land.
Yeah.
Which is nice.
Nice. Yeah, that's cool. So other things that you miss from Scala and Rust, or wish were different in Rust, or things that you just absolutely love about Rust?
Yeah, there are a lot of things I really love about Rust. I like the proper ADTs, I think.
Yeah.
So the enums and the structs. The lack of subtyping is potentially annoying in some cases, but on the net, I think I am well acquainted with programming without subtyping from my days as like, well, obviously C programmer, but then Haskell and PureScript and whatnot. So I find that comfortable. It is
Yeah.
comfortable to program without subtyping, and it prevents developers from doing a lot of terrible things. Because subtyping, it's just no one has found a way to give a subtyping in a package that is 100% safe. It's a difficult problem. And as a result, just you can get yourself into awful messes with subtyping. You don't have to worry about that with Rust.
I'm
The
happy with just having subtyping taken off the table. It's like,
Yeah,
yeah, you can, if you want to
You're not
do
missing it.
something that's like inheritance, you can use composition and you don't
yes,
run
that's
into it.
right.
And it's like, yeah, I don't actually miss it. Like,
Yeah,
So
I,
you
I
have
would agree
not
with
run
that.
into cases where you're like, God, I really wish I had subtyping here.
no, because you can make
The
it happen
case
if
would,
you need it.
yeah, there would be a case maybe for like if you had something that was like Zio environment. So the contravariant subtyping there in Zio is very, very nice.
Yeah.
But on the other hand, with the tools Rust does give you, like type classes and macros, you could probably just do as
Yeah.
good a job. It would be different, but
Yeah.
you could probably do just as good a job without having to introduce subtyping.
And another thing that I've got really excited about was when I discovered that so Rust generics has covariance and contravariance, but there are no annotations. You don't have to think about it. And that's because of the lifetime system. And
Ah,
initially, I thought the lifetime system was just, oh, it's just so you don't have to have a garbage collector. But then I've been discovering these cases where it solves these other problems and it goes deeper than just getting rid of a
yeah,
garbage collector.
yes, I agree with that for sure. Um, the power of the macros I really do like.
Mm-hmm.
The build and package management system. I think tooling in general I really love in Rust. The stability of Rust post 1.0 version and IDE support, I think performance and memory usage are really amazing. The fact that there are a lot of abstractions in Rust that you can use and you don't have to think about, is this going to double heap usage or double memory churn or
Zero
slow down
cost
my
abstractions.
application by a half, and it all starts up instantly, right? You can run a
Yeah.
big server in 20 megabytes and it just starts up instantly and it can handle lots of traffic, and that does not exist in the world of Scala or on the JVM. Generally, I think we
Yeah.
have a problem with slow startup times and memory usage and just
And you don't
costly
have to
abstraction.
tune the JVM.
Yes.
It's like, no,
No knobs.
that's no knobs. It's just gone. Yeah.
Yeah.
Yes,
Oh,
that's nice.
so,
I
I do
enjoy
have a
that.
number of Zio apps running serverless with GraalVM and get that
Ooh,
instant startup and lower heap and
yes,
it's a good way to get some of those benefits,
yes.
but it it's there's a cost to doing that.
We tried with our product Golem. We tried to build a command line tool using actually Zio CLI, because Zio CLI
Uh-huh.
is wonderful, just
Yeah.
amazing. I think I helped, but I was not the main person behind Zio CLI. It's been a lot of people, so I don't feel ashamed in saying it's one of, I think, the most comprehensive set of features in almost any CLI library out there. You get the autocomplete, you get the man docs, you get wizard mode, you just get all this stuff for free. OAuth now. And we tried to use that, and then we tried to make it fast startup time with Graal. And okay, we have some very smart engineers working here at Cyberge. I'm happy about that, and they worked hard, and they're just running into all these difficulties, and it's so fragile because mainly because of Netty. So I understand
Mhm.
that's not necessarily um,
Yeah.
a common experience, but it was so painful and so fragile that we decided it would be simpler to rewrite the entire thing in Rust than to go down the path of making it work with Graal.
Yeah.
And I honestly think Oracle I think it was a good decision what they did to donate the community edition to the OpenJDK, and I hope that makes this. I want to see Graal the default, and I want to see it supported everywhere by all the libraries and no configuration, no setup. That would be an amazing experience, I think, and would help um, ensure that the JVM can maintain its large market over the long run.
Yeah, having the ability to go native when you need to, and having
Exactly.
it work well. But I think you've highlighted it takes an ecosystem for this stuff to mature and get to the point where you don't have to hassle with it. And I've certainly had a lot of hassling with GraalVM to make it work
Yeah.
with ZOCLI, with all
Yes.
sorts of different things. And
I
there's
watched
some
you beat
challenges
on
there.
it for hours.
Yeah, there's some.
Oh my gosh.
And other people are like, what's the big deal, right? It's just, why are you spending hours doing this? It's just like,
right. just
why is it so hard?
use something that supports natively. So let's switch gears to Golem. So we you announced about a month ago the new cloud service
That's
called
right.
Golem. Golem. Am I saying that
Yes.
right?
Beats me, but we say it Golem, I think, generally.
Golem.
So it doesn't
Just to
sound
not
like Lord of
confuse
the
it
Rings.
with,
The
yes,
precious.
not Gollum. Don't pronounce it Gollum.
So
people will.
give
I
us
know
just
they do.
give us the summary elevator pitch on Golem.
Well, it's a serverless cloud computing platform that focuses on durable execution. And how you can sort of differ or explain durable execution is, let's say you write a program or like a checkout process for your cloud app, and you got to do 5 things. You got to charge the credit card, you got to get the shipping label, got to reserve inventory in the warehouse, dispatch the order to the warehouse for fulfillment, and ultimately send the user an email when all of that has been done. And you can't really afford to get all the way to charging the user's credit card and then not do the rest, right? So that is an application that benefits from reliability and robustness. And as programmers, we know how to make reliable and robust systems, but it's not so simple as writing, 20 lines of JavaScript that just do these steps in order. Like, you can describe that process just in a few words, right? In a few sentences. But then when it comes time to implement that, you need distributed systems engineers who know about event sourcing and building sort of finite state machines that are deterministic. And then you need to do recovery. And then you're probably going to be using Kubernetes and all this other stuff. And you can't easily build systems that are distributed stateful systems that are reliable and robust. And whether that's checkout for like an e-commerce app, or whether that's like ordering a ride for Uber or booking a hotel room, all of these processes, they need robustness and reliability. And we know how to solve this problem. I've done it myself many times using sort of cloud native best practices. And partially this is why, so many companies are using Kafka, right? Because it really does help you solve the distribution and statefulness problems, but it's not simple.
Right.
And
Oh
in
yeah,
my
the
ideal vision,
architecture to build what you're talking about in a actually reliable way is monumental. Like it sounds very simple. Oh, I
The
just need to do
problem
these
is
5
simple.
things, and I need to, make sure that I don't send the email twice, and I need to make sure that if this thing crashes, that I recover
yes,
and continue the
yeah,
process.
Each
And
step requires, oh yes, and we have to make sure that nothing falls on the floor and we back it up, and if it
that's right.
fails, we can recover. That's like every single step you have to do that.
it sounds so simple, and then
Yeah,
the actual reality of building that is just like
it's insane
it's insane. Like most
Yeah.
engineers.
because we're doing it over and over and over again for every single application.
Yes.
Oh, and then let's make it low latency across the globe.
Right.
Yeah, we want
And
that.
it's not just code anymore, right? It's code and infrastructure, and you've got to know about the infrastructure and how it works and how to manage it and provision it. And it makes your code 100 times bigger and 100 times more complex, and then you go slower because you've got all this technical debt.
And how do I test it?
And what if your system just magically took care of all that redundant,
Yeah.
that duplicated stuff every time?
Yeah.
And then you could say, oh yeah, I want to do this and this and this and this. Just do it.
Yes.
And it sounds
exactly.
like that's what you're talking about, which is something I have fantasized about I don't know, I think it's ever since I learned about how Smalltalk worked and how it
Yeah,
kept an image. And it was just like, yeah, rather than having to think about, oh, we got to move things in and out of the disk and we got to, why not, if it's just this imaginary space that you were
that's
living in
right.
and everything was just there and you didn't
Yes,
have to think about it. That's
yes,
what it
that's right.
sounds like Golem is.
That is exactly what it is. And it's, I think, a vision for my vision for the future of cloud computing, for someone to come along and like write that checkout process in just 30 minutes and deploy it and it just works, or to write an Uber app. You should be able to write the next Uber app, ignoring all the fancy details and user interface design elements and whatnot. You should be able to write like a backend for Uber in a week, right? It shouldn't be that hard. And if the cloud is right now, today's serverless platforms, they give you automatic scalability. You put your lambdas or functions in the cloud and they scale it up and down. That's great. How I think about durable computing is it gives you automatic robustness and reliability. You don't have to think about that anymore. You don't have to factor your application in any weird way in order to get that. It's just a built-in property of the cloud. And I think the question that we're still trying to figure the answer out to is, if you combine the automatic scalability of serverless with the automatic robustness of durable computing, how far does that get you? Like, could you build whole cloud applications using just those two things? And obviously, other cloud services. You're going to call this API, you're going to call Stripe to charge the credit card, and you're going to call this other thing. Obviously, that, and occasionally a database when it makes sense to do so, not because you need to. You should never be forced to use a database or Kafka or anything like that because of unreliable, fragile computing. Right? The opposite of durable computing is fragile computing. And right now, because everything is fragile computing, we've got to use databases and persistent queues and all this other stuff when we don't necessarily want to.
Just to work
Uh,
around the fragility of the compute layer. And that
exactly.
was a big part of the whole cloud native thing, is that, well, your compute's going to break a bunch. And so
Yes,
let's give you some patterns and architectures to deal with that.
that's
And
right.
what you're saying is, no, the cloud platform should give you that reliableness so that you don't need to have all these architectures and patterns and external data stores and,
That's right.
put things in all these different places to deal with the fragility of the compute layer.
That's
Let's
right.
just give you a stable compute layer.
Is security part of this story?
I think it is part of the story. And I think it's part of the story for a lot of serverless in general, is just the fact that it simplifies. I mean, it pushes more into the cloud. In the serverless environment, your server is the cloud. So it means they can take care of a lot of security related concerns and call your function. So you no longer have to worry about certain classes of exploits and denial of service attacks, and you don't have to worry about contamination, cross contamination, because every request is totally isolated from every other one. So that means that, like on a single server, you have to worry about sort of contamination. One request can end up contaminating due to security exploits or just using too much memory or CPU. You've got to worry about the capacity of one request to take down all the others or to see something it shouldn't. And in serverless computing environments, they're totally isolated. Every request has no ability to talk to or see or contaminate or take down any other request.
They're all
So
pure
you
functions.
exactly. So I think you have increased security just due to the nature of serverless. And then durability, I don't think necessarily adds anything on top of that, other than if you can't use durable computing, if you're forced to use fragile, then obviously you're going to be using Kafka and all these other different technologies, and that's going to open up many more potentials, I think, for vulnerabilities and
The
leaks and
more
whatnot.
complex your architecture is, the more attack
Exactly.
potential attack vectors there are.
Exactly.
So, how do you pull off this magic? What's the mechanism underneath all this that
Well,
makes it
yeah,
work?
I think so. First off, it's not like we're the first ones to ever do this. In fact, you can buy, there's certain, I can't remember the name of the model, but there's actually some mainframes you can buy that are multiply redundant, and their CPUs execute in lockstep. Okay, so it doesn't matter what fails. Basically, anything can fail, at least on that mainframe computer, and typically they're used for financial transaction processing. So it's going to continue. Right? Nothing, basically, it's invincible. So it's not necessarily a new idea.
So
Reliable
Golem
computing.
brings the power of the mainframe to the serverless cloud.
I love it.
There we go.
The image of a
Tagline.
big clunky mainframe, right?
Yes.
But yeah, it's like it's the first, I think, attempt. I mean, not the first, but we're doing something different here, and I'll explain what that is in a second. But basically, we're trying to bring the reliability of those very high-end mainframes without the cost to commodity cloud platforms. So basically, low-end junk, right? Get the reliability of the high-end mainframe, but on low-end sort of commodity cloud junk. And I think that's pretty new and that's different. And how we're doing it is actually, I think, an interesting part of the story, because it's not really possible to do that in general. Like, you can't take an assembly language program, so machine code. You can't take machine code and execute it reliably in commodity cloud platforms at any reasonable cost. Maybe there's some way to do it involving massive performance overhead, but that's partially because the spec for machine code, if you will, is too wide open. We've got, all these different architectures and tons of instructions and interrupt handlers and all this low level stuff that, oh my goodness, it's just so much that you can't do that in any performant way. It's
It's
impossible.
too unconstrained.
It's too unconstrained. I don't know if you've seen Runar's talk on constraints liberate and liberties constrain. It's a
I do
really
remember that one.
excellent
Yeah.
talk if you haven't
Yep.
seen that. But it's so absolutely true. And here, WebAssembly provides you with this very tiny, simple, deterministic virtual machine. And it's so simple you can actually look at it and understand all the different instructions. And it's portable, so it can execute on any architecture, whether it's in the cloud, on RISC or x86, or whether it's at the edge, or even in a phone or in a browser. Right? That's pretty amazing right there. But that's not a reason to use it necessarily, but it's a pretty killer use case for designers of cloud infrastructure. And so, looking at WebAssembly, it actually becomes much more reasonable to provide a way to execute WebAssembly, so a WebAssembly runtime that is capable of durable execution. And the way Golem Cloud does that is a combination of different techniques, but it's part of it is powered by the fact that in WebAssembly you you can't execute arbitrary machine code. Rather, you execute within the virtual machine, and you can only basically change state. Right, so you can do the effective state. In functional programming terminology, you have the effective state. That's it, the effective state. If you want the effect of HTTP or sockets or system time or anything like that, file systems, then you get it from the host environment. So the host environment provides you that environment, and there's two different environments. Basically, there's the sort of browser environment, which has all the JavaScript stuff. But for the type of WebAssembly we're focusing on, it's back-end WebAssembly. And in that world, there's this standard called WASI, which could be thought of as the POSIX of that world, that defines the sort of, you don't use POSIX when you're writing your Java program, right? But Java uses it when it's implementing a standard library. So it's basically the low-level layer that ends up powering everything in your standard library and in that whole ecosystem is WASI. And so what we do in Golem Cloud is we have our own implementation of WASI that is aware of every time you make a random number or get a system clock or write to a file or create a socket, make a HTTP connection, and we're able to see all of the inputs and outputs to your program.
Yep.
And that gives us the ability to say, oh, well, we know exactly how to recreate the state of something during a failure event. And we can basically do our own version of sort of event sourcing on the back end, keeping track of all the interactions with your program, combined with snapshotting, because we also have access to the full linear memory of your program. So we can see everything, the state of the entire program. We can see that, and we have access to that. And we can pause your program because it's a WebAssembly runtime. And so the combination of these techniques lets us give you durability. And it's almost as if the whole state of it's not implemented like this because it would be too slow, but it's almost as if the state of your whole program is being continuously snapshot, but in a way that is super lightweight and only has, relatively low overhead.
So it sounds like every effect is an event that you capture.
It's not necessary to capture every effect. And remember, you have the basically pure CPU work. You don't need to do anything because that's deterministic and you can recreate that in the event of a failure. So it's really only certain types of interactions with the outside world, any certain types of side effects that need to be captured and committed. And an example of one that you don't need to capture and commit is create a local file, write to the local file. Right? All of that is totally fine. And the reason is we can recreate that local file through playback. So we don't need to necessarily do anything with that. Whereas if you go make an HTTP call, well, that's an external system. The state of that can be observed from the outside world. It really goes down into what is the nature of a side effect. And in FP, this is why, my background in functional programming is finally coming in use, right? I mean, not to say that it's useless, but it is a bit academic. But it's like, okay, in FP, we even say the function is pure if you cannot observe all the mutation and other nasty tricks going on inside the function from the outside world. And it's the same way in a WebAssembly environment. You can regard that as sort of pure or replayable, deterministically replayable, if you cannot observe anything from outside the world. And you can't observe a variety of changes like local file systems, environment variables, stuff like that, random number generation, all that stuff. You can't observe it until the moment where you go do something that interacts with the outside world, and you can therefore observe everything prior to that point. So you have to either snapshot or hold on to those individual events.
So Wasm gives you the ability to have hooks into the side effects so that you can do that, like snapshotting and keeping track of state changes so that you can automatically resume something. So let's say one of your servers
Yes.
crashes that was running some process. You've got your ability to then resume exactly where it was because you've been observing all the side effects, and Wasm gives you the right hooks or the right pieces to do that you maybe could do on the JVM with JVM bytecode and an agent, but oh my God, probably too complicated. And you certainly couldn't do in a generalized way across
That's
any
correct.
runtime. And
That's
Wasm
exactly
gives
correct.
you exactly what you need to be able to do that
Exactly. It
correctly,
gives
no
us
matter
that.
what the host programming language that created that Wasm was.
Exactly. It gives us that combination of sort of strong sandboxing where we can observe everything your program is doing, which is important for replaying. And replaying is useful for several different cases. And then also it gives us access to the linear memory and state of your program so that we can use that directly. Because in some cases you want to replay, in other cases you want to snapshot everything or at least some subset so you can do a faster resume. So we have that combination of features to enable that that's not possible with machine code and might be possible with the JVM if it weren't for lots of, the JVM is not a total specification for everything because we've got all these native methods that are implemented in C that you call out to. That's how Loom works.
Yep.
So lots of parts of the JVM that aren't official part of the spec, but are in fact an official part of the way Java works. So I'm not even sure if it's possible with Java. It is possible with WebAssembly. And the nice thing about WebAssembly is it can bring this technology of durable computing to, in the limit, every programming language. Right? In the future, hopefully, 5 years from now, you just turn a switch on in your compiler, and instead of making machine code, you make WebAssembly code. Like hopefully nothing else changes. You just turn a switch on. We're not there yet.
Yeah.
As you
That's
discovered, didn't you?
Yeah. Kotlin I was trying Kotlin Wasm on Golem, but yeah, it's all moving very quickly. And you were just at Wasm Con or whatever, and I'm sure got excited about the trajectory and the momentum that's happening around Wasm. It's pretty amazing.
It was great to see. And I talked to some people who have been in this space since the very beginning, and like even before WebAssembly. I don't know if you remember something called asm.js.
That's right. Yep.
Yeah.
That was the origin of WebAssembly, wasn't it?
Yeah.
Yeah.
So I talked to some people who've been around from there, and they say like in the past year, WebAssembly has just gone crazy. Progress is being made at a very fast rate. more bigger companies are showing an interest in putting some money and advancing the tooling. And then, of course, we have more and more programming. Like, I think what JetBrains is doing is really smart with Kotlin. They're like, we're going to support WebAssembly. And they're going to succeed. It's just a matter of time. And they're going to have it way before Java, which is great. It's a good selling pitch, I think.
So is there also some kind of, because you mentioned with the mainframe there being multiple processors in lockstep.
Yeah.
So is there that kind of redundancy in Golem as well?
We don't have that yet.
Okay.
So right now when a failure event happens, we have to detect it. And then we have to say, oh, it looks like we have to restore the state of this program on a new machine, and then redirect requests to that on that machine. So ultimately, it will be interesting to see what direction our technology takes. But we could, imagine some use cases where you cannot afford much of a delay at all. You want like instant. In the financial transaction processing, you don't want to slow down you don't want to pause transaction processing for 30 seconds or whatever it might be. You want it to continue right away. So in those types of scenarios, you can imagine, it depends on sort of how user base goes, but you could imagine in those sorts of scenarios having to pay extra, or you would have to pay extra for that. I mean, in terms of CPU and memory, if you want to actually be able to do instantaneous failover when a failure event is detected. I don't think there's any reason why it's not possible, though.
Yeah.
Are there languages that aren't going to be able to work with Golem? Because I would think that there are some that are just not, I don't know, robust enough to work with it.
I think in theory, pretty much because the WebAssembly spec is Turing complete, there's a way to make every language work with it. Now you may have to pay some tax for some languages because of features that they use, which are not supported in WebAssembly, which might be supported in machine code or whatever other target. And an example would be right now, garbage collection is a real weakness. You've got to bring your own garbage collector. And the disadvantages of bringing your own garbage collector, well, there's many actually, and in combination with some limitations with Wasm, it just makes it very painful and slow to bring your own garbage collector to Wasm. And then another example of something that is difficult to support is multi-threading. So that is actually going to happen, but it hasn't been there. There's only sort of alpha stage support for multi-threading in Wasm.
So part of what's fascinating with Wasm is that all these like things that aren't there yet seem like they're all in the works. It's like you've got Wasm GC like in the works. You've got Wasm threads in the works. You've got the Wasm
and
component
they're like implemented,
model.
And there's at least one runtime out there you can experiment with it. So all these things in the works are actually pretty far along, and it's interesting to see from I wasn't involved in the WebAssembly space until recently, but it was eye-opening to just see, okay, it's a big problem, right? They're building it's like the JVM all over again, or it's like, building a new CPU architecture and saying, okay, we need to make every compiler in the world support this, right? And also we need to make sure we have the right set of instructions so that every language can target this. It's amazing to see just how far they are along down that path. They have plenty of room to go, but they are pretty far down that path, and it's pretty exciting.
Yeah, and then one of the benefits for you as a cloud provider around this is that because Wasm was created for the browser, it has good sandboxing, and sandboxing is something you need as a cloud provider.
Yes.
And so it's like, oh, we just get that for free. Awesome.
Exactly. And like I said, it's the strongest type of sandboxing because the overhead of Wasm is so low and can be made so low that you can afford to spin up a new program for every single request.
Yeah.
And that just gives you, it's not just that. It's even if you're using one program to service a bunch of requests, that program has no ability to interact with anything unless the host environment has provided it access to. So that means that in contrast to the containerized world that we live in right now, where every program ships with their own sort of virtualized environment. In the world of WebAssembly, it really can be a single process that is running all of
Yeah.
your tenants
Yeah.
in a 100% secure way with no possibility of cross contamination. And of course, we're not there with containerization, never will be, because containerization solves a bigger, older problem, which is all these different programs using their own different operating systems and have their own file system and everything else. And it's just you could almost see if Wasm works out, it may be a lot bigger than just like durable computing.
Right.
It could be like people say, oh, this is the way we always should have done cloud.
Right. Yep.
I think that's the vision of many people working in WebAssembly right now is might be the way that we package up and ship applications. And also, I don't know if you've heard about the component model, but the component model lets you build a library in one programming language
Yep.
and consume it in another.
Yep.
It's part of the
All
vision
of
of the
a sudden, we
JVM.
have actual like FFI across every programming language with a common way to communicate. And yeah, I mean,
That's right.
the Wasm component model is definitely one of the most exciting pieces of the
Now,
whole
is
space.
that part of WASI 2, which I just
Different
read
than
about this
WASI.
Okay.
Yeah.
Yeah.
It's yeah.
A different specification, but
Okay.
yeah, WASI Preview 2 is the new WASI model.
Right.
Yeah, the WASI stuff is built basically on the WASI stuff right now is pretty much built on the component model. So there's basically something called WIT, which allows you, it's like protobuf basically, but for the WASI world. And what it allows you to do is describe the interface of something. And there's thought that in the future, languages could natively use WIT. They could generate and consume WIT such that you wouldn't need to do any work to, from Rust, call a JavaScript library or vice versa, with a sort of translation between those types, all idiomatic in their respective languages, and then handled automatically by the runtime. It's a very grand
You've
vision.
talked about using like gRPC as a FFI layer because then you get the shared definitions and all that. But the problem with it is that you have to go through a socket, and with WIT and with the Wasm component model, you get those benefits, but all then in process in Wasm.
It just sounds magical, and it's another one of these things where I go, I was born too early.
I know we started doing things that probably should not have been done for many decades, but we found a way to make it work, and we delivered business value, and that's what matters.
Well, is there? I know you're not publicly traded yet, but I feel like this is something that I want to get a piece of this because I feel like this is going to change the world.
We're very excited about it, and it's good to hear that feedback because we're still experimenting with how do we talk about technology like this, because we've seen some responses that are like this run, right, and it's like it's really like people are like, wow, that broke my brain. I don't even know how I would write software in a world in which computing is durable instead of fragile. But they see the potential for how that can change. And then other people were like, what? Durable computing? What does that mean? What's going on here?
Imagine the majority of people.
It's just hard to imagine.
Well, yeah, there's so much foundation you need to get before you go. Well, it's kind of like what we were talking about with error handling. It's like you get to a certain point and you go, oh, well, obviously we have to do these things. But before that, it's like, what?
Yeah,
exactly. That's somebody else's problem. I don't have to worry about errors. My code won't fail.
Yeah.
How do you get
we've talked mostly about Golem in the case of kind of REST services or server oriented stuff, but it seems like stream processing is another huge opportunity here because dealing with failure recovery in stream processing is massively hard. How do you parallelize stream processing? Like the whole stream processing space should be on a foundation of durable computing. It would make things so much easier.
Yeah, I've thought about that is like, okay, well, you never know. When you're doing a startup, you have to be agile and you have to respond. And right now we're saying, hey, maybe you should consider durable computing instead of fragile computing for some portion or like even a tiny little piece of your next cloud app, right? But who knows? And one of the things that I've been thinking of is if the market's too early on that, it's just how easy it is to come up with like a domain specific solution that targets a specific pain point that just happens to benefit from durable computing. And streaming data processing is one of those, right?
Yeah.
Imagine Spark,
Yep.
but on Golem.
Yeah. Exactly.
It's just amazing what you can do when you have the guarantee that as individual nodes fail and go down or are restarted or whatever happens, that the overall computation as a whole is just going to continue unperturbed. And you don't have to write complicated code to do that. So, like having a system in place where you express your analytics pipeline and compile that down to Golem, in any programming language of your choice, right, Rust or whatever, and then distributing that by uploading those workers or instantiating those workers in the cloud, that could be pretty interesting. I think there's a lot of, or even like, how would it be to build a distributed SQL database if your nodes don't go down?
Right.
Becomes
Exactly.
a different type of problem, right? You just spin up 1,000 nodes. Every node handles a fraction of your data, and then you never have to worry about your nodes going down. Resizing is comparatively easy if you never have to deal with your individual database nodes going down. So I think it opens up the door to build things like databases and Sparks and whatnot in a new way that no one has seen before. And I think that that's very interesting. And if we're we're not yet obviously selling anything, we're just trying to get people to use us and give us feedback. But if we encounter if it's breaking people's brains and we're not able to get people's heads wrapped around this concept as a cloud computing platform, you might just see us try to take on one of those use cases, which I think would be really interesting.
For sure. And to wrap us up, is Golem built with Zio or with Rust?
Both.
Nice.
It's built with
Awesome.
both, yes.
Oh,
So for the front end APIs, they're all powered by actually Zio
nice.
running on Scala 3.
Nice.
And that allows us to move very, very fast because Zio is just, in particular, we use Zio HTTP, and we used an even more experimental part of Zio HTTP, which is endpoint.
I'm looking forward to your endpoints change.
Yes, yes. So we did a lot of stuff. It's all written using more or less master. I mean, not quite master, but bleeding edge stuff in Zio. And it's because using these endpoint definitions let us generate like the Rust CLI code and get all this stuff for free. It's just amazing how much power that gives you. And of course, we're familiar with the Zio ecosystem, and it's very good at building robust, resilient web services. So the front line is all Zio and Scala 3. And then the sort of back end of our back end is written in Rust. And it's the point that needs to be highly scalable and super low latency and very performant because we want to make this as cheap as possible. We want
Yeah.
to approach the cost of fragile computing, but in
Yeah.
a durable package, because I think that's a benefit that's hard to argue with at that point. And Rust is a perfect language for doing that. And then Rust also, I think, has an amazingly mature WebAssembly ecosystem, and everyone there is taking
Yeah.
WebAssembly seriously. The Rust compiler, you just add a command line flag, and now it produces Wasm 32 ASCII.
Yeah.
That's amazing. And you don't see, and several of the leading WebAssembly runtimes are written in Rust. So it's just a perfect fit. In addition to all the other reasons for choosing Rust, WebAssembly is yet another reason to choose Rust.
Nice.
So before we go, you made a comment on the site formerly known as Twitter. Sometime
I don't even know what to call it.
Yeah, right, whatever.
Xing on X. I don't know what
Yeah,
Elon is
you
trying
did
to
an
do
X
there.
on X, but anyway, you were talking about you had some insight about concurrency, I think,
Yeah.
Parallelism.
and parallelism. Can you
Yeah.
replay that for me? Because I've gotten insights from you guys before that have kind of really changed my perspective on things, and so I'm looking for that here.
Yeah, happy to share that. So I've been doing multi-threading from the very first days. When there was the very first way to do multi-threading in C, I was there doing multi-threading, and I've seen that whole journey, and I've seen obviously software transactional memory in the FP space, and then mutexes and channels and all the other primitives, and even like beyond that to like concurrent systems, concurrent communicating processes, and so forth that people have experimented with. And here's my conclusion: is that there are some better systems out there for expressing concurrency. Will people use them? No, and that's because languages are built around threads, right? All languages out there, they're built around threads, either single threaded or in some cases multiple threaded. And it's basically one, threads have one. So even though threads are not the best way in theory to build concurrent systems, they have one. But they are ridiculously complicated, okay? It's very complicated to build correct multi-threaded code. And there are lots of reasons why that is, but there's a big one that's easy to fix. And that big one is parallelism. Okay, so in my experience, we can't go all the way and say we're going to radically change how we do concurrent computing, because that's new languages, that's new paradigms, that's rip and replace. Throw away everything you have, learn something new. That can't work in the real world. Our industry is one of band-aids. We just keep on throwing band-aids on top of band-aids and band-aids, and everything makes us a little bit better, and then we end up with big messes that we all have to live with. So we can't do that. What can we do? Well, we can say, okay, well, concurrency is here to stay, and the threading model is even going to work, right? It's going to work not well, but it's going to work with what people have, and it's going to allow you to do X, Y, and Z, because people need the ability to say, I want to do these 3 requests in parallel because of latency. The requirements are just too high. A language that only allows you to do this completely before you move on to this, that's not going to work, because the database has got to be working at the same time as that API call to get the latency down low enough. So we need concurrency. Threading is the model that we have. It's not great, but it's here. The one demon that we can eliminate, if we choose to do so, is parallelism. And parallelism is that ability in most, if not all, programming languages to have multiple threads running in parallel. And they're actually running in parallel because those threads are executing on different CPU cores. So the huge complication that brings in your programming language of choice is the fact that it is possible to access the same memory at the same time from 2 different cores. And this leads to all sorts of problems. And not only does it lead to problems, but it prevents us from solving a large class of concurrency problems. And what that large class is give me a construct like atomic that lets me just wrap some code in atomic and make changes to mutable memory. Right? That could be possible. It could be possible very simply in a model of programming that is concurrent and not parallel. Okay, if you have concurrency but not parallelism, then only one CPU core is ever touching the memory. And you can reason about that in a way simpler fashion than you can. And also it would be a massive simplification to Rust, honestly, if Rust didn't have to worry about multiple cores having to access the same piece of memory at the same time. So deleting parallelism would allow us to not only tremendously simplify the way we reason about our concurrent multi-threaded programs, but also it would enable us to introduce new goodies like that atomic block, which we can't really think about doing right now. Atomic blocks could cover as much or as little as you want, and they wouldn't necessarily have to be restricted to memory. And the reason people always say or give for keeping parallelism around is, well, we need it. Well, I think JavaScript and TypeScript have demonstrated we don't, right? Accidentally, that's the model of concurrency that they have. They have concurrency, but no parallelism. It leads to a massive simplification in the way a lot of frameworks are designed to have concurrency, but no parallelism.
So
very simplified.
Isn't what you're describing traditionally called thread confinement?
Thread confinement?
Yeah, where it's like you have something which I guess maybe it's a little different, but the idea is that you only have a single thread, so that your tasks can't step on each other's toes. And I thought Tokyo's async only used a single thread to drive things. Maybe I'm
You can, what you really want is you want every single thread in your programming language or its standard library to be a green thread. And you want the execution of all of these green threads to occur on a single operating system level thread. So therefore to be scheduled on at most one core. You want your program as a whole to only ever be executed on one core at a time. The core can change over time, but you want it to be executed on one core at a time. And if you have that guarantee, it not only simplifies the way you program, but allows you to introduce new types of contracts. And you don't actually sacrifice a whole lot. Why? Because even though people will say, hey, it makes your code slower, the reality is we have insane amounts of parallelism already in the typical business application. Right? We have parallelism at the level of database requests and all that fun stuff. We have parallelism at the level of request handlers. We have, 1,000 concurrent requests, and then we have parallelism inside the virtualized operating system, all the stuff that's doing, and then we have parallelism because we're virtualizing a bunch of different operating systems on the same machine. We have no problem saturating CPU cores, regardless of the fact that we're running, single-threaded TypeScript servers on the back end.
So no application level parallelism. Move that out to the
Yes.
operating system or other.
But
other
otherwise,
ways.
don't change. Like your programming language can be the same. There's no need to rip and replace any code that you have, which is why something like this could work. And then you could introduce something new, which gives you the ability to do things atomically on that single CPU core that's executing all your stuff. And I think TypeScript, server-side TypeScript, server-side JavaScript has demonstrated it's a viable model for the vast majority of business applications. There's still
well in
cases where you
Python
don't
too.
want it. Oh yeah,
Python's async will only run a single
yeah,
thread at a time, and everything gets sped up,
yeah.
and you have the safety of not having multiple tasks. And then the true parallelism is kind of a special case. You go, oh, I am actually doing heavy CPU
Yes.
intensive things, and I break that up and I put those on different.
That should be the basically we should not all have to pay for the cost of something that almost none of us need. The scientific programmers, they need that. That the AI programmers, ML and stuff, you need multiple threads, you need CPU parallel work. You need it in those domains. Game programming, you can argue you need that for some things in game programming. Business apps, I really don't see. As much as I, love thinking about hard problems in parallelism and concurrency, I don't see the business justification for any of it, and it just adds a tremendous amount of complexity.
The one big argument I've heard, like especially in the node world, is the overhead of the VM. And if you are going to use operating system parallelism, you're duplicating that application and VM kind of overhead for each parallel instance.
Yes.
And maybe Wasm is the way out of
Yeah,
this.
right. Wasm's what got me thinking about that,
Yeah.
honestly, is hey, do we need, because we have all these independent Wasm programs executing inside a single process, do we even need all of this anymore? Or is it possible that parallelism inside a single program is overrated? And even these days, I'm thinking that, okay, I think that argument is sound and it's hard to critique. I think you could go further and say for like maybe 80% of business cases, it shouldn't even be concurrent. You should just have A, B, C. But to go all the way there, right, you might need an argument. I want to talk to that database and do it in the background. Like, give me something in the language that lets me say, do that in the background and not block my current flow. But it's clear that we don't
Like
need the
Loom is
full
showing
amount.
us that hey,
Yeah,
we can have these benefits without cost.
that's true.
Yeah.
Yeah, that's true.
Okay.
Awesome. Well, John, thank you so much. We're super excited about Golem And
I'm
thank
glad
you
to
for
hear
all
that.
your
Thank
work
you.
on
Oh, yeah.
Zio, and
It's a pleasure.
you've done such an amazing job helping move the industry forward in so many ways. So appreciate all
Thank
your
you. I appreciate that.
contributions.
And thank you again for having me on the show. I really
Oh, it's been
appreciate that.
great. We've been waiting
Yep.
until the right moment.
Yep. And it was awesome.
Yeah.
Thanks.